In this video, I will be talking about 8-1 using variables to write expressions. This is the first lesson in topic 8, which is about numerical expressions, patterns, and relationships. So basically a little introduction into algebra. So here we go. First of all, we need to discuss what a variable is. We've talked about it before this year, so hopefully it rings a bell to you. But a variable is any letter that represents an unknown amount or some number, but we're not sure what that number is. So to represent this unknown number, we use a letter, a variable. So we might use something like n. N is a variable that's used a lot in math, or x. X is also used a lot, y. But really, we can use any letter of the alphabet to represent a quantity that can change or vary. And variables help us translate word phrases into algebraic expressions, which I will show you on the next slide. If I have the phrase 4 plus a number y, I need to use variables, operations, and numbers to represent this word phrase as an algebraic expression. So remember, an expression is something like 1 plus 2. There's no equal sign. Once we get the equal sign in there, it becomes an equation, not an expression. But today, instead of having all numbers and operations, 1 and 2, we'll have some numbers, some operations, and then a variable in there. So maybe a plus 2 or something like that. So we're going to look at the words that we have up here. And when we're looking to start these algebraic expressions from a word phrase, we need to look at a couple of things. We need to pay attention to the number that's given to us. There will normally be a number given to us. The variable that we should be using, in this case it's y, and then any key phrases that tell us what operation we need to do. So in this case I have the key phrase plus, and I know that plus means I need an addition sign. So reading this whole thing back to myself, I have 4, I'm going to write that as a number, plus, I have my plus sign, a number y. 4 plus y is the algebraic expression that would represent this word phrase up here. And really all you need to do is kind of read it to yourself, read it out loud, use what you know about operations and numbers in order to think how you would take that word phrase and turn it into a math phrase, an algebraic expression. In this case, things are a little bit trickier. I'm going to go through again and find out my numbers that I need to use, my variables, and any key phrases that tell me what operation I'm going to be doing. Here I have more than. I know that more than also means plus. So I don't have plus like I did last time, I have more than. So we need to kind of think this through because plus and more than result in a tiny bit of a different algebraic expression, but it's really not a big deal. I have 2 more than a number z. So what that means is that I have this z, whoopsies, and I'm going to say that z is, I'm going to kind of draw you a picture, like here's my number line, here's z on the number line, okay, whatever z is, and I have 2 more than that, so I'm going to go over 2 spaces on this imaginary number line. So really, I'm starting with z and then adding 2 onto that. Even though the 2 appears first in my phrase, it comes second when I have that phrase more than. If you think about it like a number line, it really helps. If it had said 2 plus z, I would be starting with 2 on my number line and adding however much z amount to that. But I'm starting with z, 2 more than z. So we start with whatever z is. So in this case, my algebraic expression is z plus 2. You all should have this chart, and if not, it's on my website. But this will be a helpful chart to show you what operation you might use if you have different key phrases, like something like more than, the sum of, the product of, divided by, divided into, things like that. So in the next few slides, I'm going to go through each operation and show you some examples of when you might use an addition sign, a subtraction sign, a multiplication sign, or a division sign. Let's talk about addition first. So when we have the operation addition, a couple key phrases that might tell us that we need to add is more than or the sum. These aren't the only two phrases. We might see other things like plus or increased by. So just because these are the only two on here doesn't necessarily mean that's the only phrases that mean that we need to add, but these are ones that might be a little bit tricky for us. Hopefully we know that plus means to add, that means to put a plus sign. And we're going to talk about decreased by down here, so I figured we could talk about increased by a little bit down there as well. But let's look at more than and the sum for now. So if I have 10 more than a number x, this is like the one on the last slide where the number and the variable come in the opposite order of how they're written over here in the example. So 10 more than a number x means that if we had a number line, I'm starting with x and I'm going 10 more. So I have x and I'm adding on 10 to that. So in the word phrase, 10 comes first and then we see an x. But in our numerical and algebraic expression, the x comes first. So this chart will be helpful to tell you when you put which number or variable first. Let's look at the example that I've written above. It says 8 more than a number x. So whenever I have more than, or, and we'll talk about this in a little bit, less than, I am writing the variable and the number in the opposite order than they appear in my word phrase. So I have 8 more than a number x, so x is going to come first, and then more than tells me I'm adding, and 8 is the number. So again, if we think about it like a number line, we're starting with x, and we have 8 more than this number x. So I have x, and I'm adding on 8 to it. Okay, let's talk a little bit about subtraction. Some key phrases that you might see for subtraction are less than and decreased by. We're going to talk about both of these. Like I said in the last slide, when you have less than, the number and the variable in your expression are written in the opposite order than they appear here in your words. So 5 less than a number x means I have x and I have 5 less than whatever that is, not 5 minus x. If they did want 5 minus x, they would probably say it exactly like that, 5 minus x. Or they could say 5 decreased by a number x. 5 decreased by a number x. So less than switches the order of the number and the variable in the word sentence, and decreased by leaves them the same. So until you kind of get used to that, keeping this chart around you will be helpful. Let's look over here. 4 less than a number n. That means, think about a number line again. I have n, and I'm going 4 less than that. So I'm starting with my n and then going backwards 4. If I had 4 decreased by n, that would be 4 decreased by n. So only more than and less than change the order so far. Okay. Thinking about decreased by and increased by, if you did want to use increased by, if it was 4 increased by n instead of decreased, it would just be 4 plus n. So increased and decreased do not change the order of the number and the variable as they appear in the word sentence. Multiplication, a couple things that you might see is the product of and times. What's nice about both of these key phrases that we will see, it doesn't matter the order. It doesn't change the order. So the product of 6 and y is 6 times y. 6 times y is 6 times sine y. Up here I have 8 times a number y. 8 comes first up here, so I write that first. I have my key phrase times, so I'm putting a multiplication sign, and then I have my variable y, which represents some number. For division, a couple things that you'll see for division is divided, or 10 divided by x, or x divided into 10. So you'll either see divided by or divided into. Divided by is what we're used to, so that shouldn't be too tricky for you. If I have 10 divided by x, I'm taking 10, splitting it up into x groups. But divided into means that the order of that number and variable changes. It's like asking how many times does x go into 10? We're dividing x into 10. So if we think about writing it with our little visor like this, if I had x dividing into 10, I'd have my 10 inside, because it says into 10, and my x on the outside. So whenever I see divided into, I like to write it like this first, and then I think, okay, that means 10 divided by x. So when you see divided into, the order of your variable and your number will switch. So up here, I have a number j divided into 12. So I'm going to write it like this first. Okay, I'm dividing into 12, so 12 is inside, and I have j, so that means 12 divided by j. You could also have something like this where, you could also have something like this, but have a number first, like 12 divided into j. 12 divided into j would be j, would be j on the inside, and we're dividing 12 into it, so I would have j divided by 12. Sometimes you will have a phrase that you have to have more than one operation in it. So if I go through and kind of think back to cubes or problem solving strategy, I'm going to circle my numbers. So I have 12, and over here I have 3, I see a 3, and then I have my variable g. Then I go back and I see fewer than, which gives me kind of the light bulb going off in my head that I'm going to have to subtract, but I also see times. So when you have two key phrases that tell you about two different operations, that means you're going to have one of these more complex multi-step algebraic expressions. So we need to just take it step by step. 12 fewer than something. So I'm just going to do 12 fewer than and just kind of group this whole part right here as something. So if I had 12 fewer than blank, whatever, we know that more than and fewer than switch the order of these. So I have something and 12 fewer than that. So 12 comes second. Now I can worry about what that something is, this part here. 3 times a number g. So remember, with multiplication, it's nice and easy. The order doesn't have to change. 3 times a number g. Okay? So I can write this as 3 times g minus 12, or 3g minus 12. Remember, we talked back in a previous topic about the fact that when we have times and a number and a variable, if we don't put any sign here, that means multiply. If I did want to leave it like this, I would probably, just to be sure, put parentheses around this so people know that I'm doing 12 fewer than this whole thing as a group. Here's another example where we have a couple different operations. I see the number 7, I have 4, a variable, then I have times and the difference of. So 7 times something. So I always start with whatever comes first. So I kind of think of the second part as a group. So I have 7 times something, whatever I have there in parentheses. So I have 7 times, again with multiplying it's kind of nice because the order doesn't have to change, and then I have the difference of k and 4. Remember, difference of, if we look at our chart, doesn't change the order because it's like decreased by. So the difference of does not change the order. The difference of k and 4. And I want that k and 4 to be together as a group. I'm not doing 7 times k, then subtracting 4. It's 7 times this whole thing. So I'm going to put parentheses around that whole thing. I hope this video has been helpful. Sometimes 8-1 can be a little bit tricky just because there's so many different phrases you might hear. If you're confused, watch the video again. We'll talk about it more in class tomorrow as well. I want you to try these 2 problems. This is your homework. So on a separate sheet of paper, you need to do these 2 problems, number 1 and number 2. You need to write these as an algebraic expression using a number, a variable, and some sort of operation, adding, subtracting, multiplying, or dividing. Use your chart to help you. You need to bring this and your chart to school tomorrow in order to get full participation points. Have a good night.